The iodine method for the detection of latent fingerprints is quite an old technique. It gives sharp and very strong impressions on documents. The advantage of this technique is that it is fuming in nature. Experience tells us that when we apply a solid or a solution for the detection of latent fingerprints, a good number of ridges get disturbed. Rather, many of them get damaged. However, since in this case we have to impinge vapors on the crime scene evidence, nothing happens to the ridges. They are all developed almost to 100% extent. Yet another advantage of iodine fuming method is that one does not have to visually search for the latent fingerprints. With other methods, first oblique like source is used to find out where exactly the print is, and then the chemicals are applied over it. In this case, the crime scene evidence is placed in a jar which contains a few crystals of iodine. Iodine is sublimable in nature, which means that it directly passes from the solid phase to the gaseous phase. The gaseous vapors settle down on the latent fingerprint. Chemically, they react with the fatty acid constituents of sweat. But this reaction is reversible, which means that after a while, say after a few minutes, the iodine vapors they just detach themselves from fatty acids and the print which was developed it fades away. Normally brown colored impressions are obtained on a large number of porous and absorbent surfaces. It proves to be a very good method of detection of fingerprints on documents. Moreover, supposing the technique fails, then we can use other methods such as ninhydrin method or powdering for detection of prints. The other way around is not possible. Suppose ninhydrin method fails, then no other method can be used to detect fingerprint on the same crime scene evidence. This is a great advantage. So, we always suggest that whenever fingerprints are to be detected on any unique item, the first method of choice should be the iodine method. As far as the problem of fading is concerned, even that has been mitigated to a large extent. We have found that camphor, like iodine, also sublimes. And we have conducted the reaction of camphor with iodine on the crime scene evidence. The product which forms 2-iodocamphor is brown in color and is non-sublimable. So once it sticks to the latent fingerprints, it remains there. So unlike pure iodine, the prints developed by which fade out with time, the 2-iodocamphor developed fingerprints, they remain permanently. So all in all, we suggest that this should be a method of choice whenever crime scene evidence happens to be a document, a letter, or a painting.
Dear students, after studying this module, you shall be able to know the significance of the iodine method, a vapor phase technique of fingerprint detection, the methodology of iodine fuming, the mechanism of fingerprints detection by iodine technique, the role of fixing reagents to prevent the fading out of iodine developed prints, and a critical assessment of iodine method for developing latent fingerprints. So let us start this chapter with a brief introduction. The iodine fuming technique for visualizing latent finger marks has been used for almost a century. Iodine is a crystalline solid which, upon heating, sublimes into violet vapors. The vapors are absorbed by the sweat deposition of the latent imprint, thereby revealing the ridge pattern. It has been used to develop latent fingerprints on porous surfaces, particularly paper. Iodine fuming is still widely used because it is inexpensive and easy, sensitive, and is non destructive because The stains it produces are ephemeral. If it is used at all, iodine fuming is normally the first processing method attempted. Some forensics texts state that iodine fuming is used less often nowadays than formerly. That may be true in the limited sense that there are now many alternatives, but iodine fuming is still used frequently by many forensic labs. It's cheap, fast, effective, and completely reversible. Initially, it was believed that iodine can be added chemically and reversibly to double bonds of the unsaturated fatty acids present in the fingerprint residue. However, it was later suggested that the mechanism of the reaction involved physical absorption of iodine on the fatty acid content. The iodine fatty acid interaction imparts a yellowish brown color to the rich pattern. Iodine fuming is a simple procedure of developing latent fingerprints. A sample fingerprint developed by iodine fuming method is shown in the given figure. Iodine fuming is an excellent way to develop prints on porous and non-porous surfaces such as paper, index cards, magazines, and cardboard. To fume a suspected latent print, the surface must be placed into a container with solid iodine. The sublimation of iodine in a closed container will cause iodine vapors to concentrate, then be absorbed by the oil and sweat left behind the human skin. The temporarily developed print will then be visible as an orange brown outline. Upon development, the print should be photographed for documentation. The iodine will eventually sublime from the surface of the print, allowing the print to return to its latent state. The surface is then returned to its original appearance and can even be exposed to additional developing techniques. Now, let us have a look on the methodology. Latent fingerprints may be developed by iodine fuming technique by one of the following experimental procedures. Let's see. Number one is fuming gun method. An iodine fuming gun is made of either glass or plastic. The butt end of the gun contains a dehydrating agent, usually calcium chloride. There is also a mouthpiece for blowing air at this end. An iodine fuming gun is displayed in the given figure. Near the nozzle end of the gun, about zero point 0.5 gram iodine crystals are placed. Air is blown, though the mouthpiece and the gun nozzle is moved above the surface, impinged with the latent prints. The optimum distance between the gun and the surface is 2 cm. As soon as the latent fingerprints begin to appear, the iodine fumes are concentrated over the imprinted area. The prints so developed are photographed immediately. Another method is fuming cabinet method. A china dish containing about 1 gram iodine crystals is placed in a fuming cabinet. The object bearing the latent prints is suspended from the roof of the cabinet. Iodine crystals are gently heated to about 50 degrees Celsius using a heating block. After a few minutes, latent fingerprints begin to appear. The object is exposed to the fumes till maximum contrast has been achieved between the prints and the background. The developed fingerprints are immediately photographed. Then comes powder dusting method. Iodine crystals are pulverized into a fine powder. The powder is spread out over the surface bearing the latent fingerprints by a camel hair brush. The excess powder is blown off. This method does not require any equipment and is therefore both simple and cost effective. However, it exposes the user to the toxic fumes of iodine. As a result, this method is now obsolete.
Iodine fuming method. Materials required: iodine pellets, glass tube, surgical gloves, cotton, paper as a surface. Procedure: let us take fingerprints on a piece of paper. Blow air over the latent fingerprints from the side of the glass tube that is not covered with the cotton plug. As you can see, the prints developed are yellowish brown in color because the iodine fumes react with the fatty acids present in sweat. Photograph the developed print.
Now let us discuss post treatment of developed fingerprints. Fingerprints developed by iodine are not permanent in nature. These tend to fade out on standing. In presence of air, the fading of prints is accelerated. For this reason, the iodine developed prints have to be photographed immediately. Nevertheless, it is possible to fix the prints by using iodine in conjunction with other chemical reagents. Iodine is known to react with starch, giving a stable, deep blue complex. Thus, post treatment of iodine developed fingerprints with starch solution gives long lasting blue impressions. The fading problem may also be avoided by pressing a silver foil onto the iodine developed finger marks. The interaction of iodine absorbed on the fingerprint residue with silver produces yellow colored silver iodide. The latter, on exposure to light, decomposes into finely divided silver, revealing the rich pattern as a stable black deposition. Iodine exposed fingerprints by may be fixed post treatment with a solution of
N dash
tetramethyl
4 dash
4,4 diamino diphenyl methane in 1,2,2 trichloro trifluoromethane. The color of the prints changes from brown to green blue. The figure shows an iodine developed print, half of which was treated with
N dash
tetramethyl
4 dash
diamino diphenyl methane reagent. The treated part is blue in color, while the untreated part is brown. Nevertheless, the quality and clarity of post treated fingerprints are not affected. Iodine developed fingerprints on thermal paper may also be fixed by spraying with a hexane solution
N dash
tetramethyl
4 dash
diamino thiobenzophenone or phenothiazine. With former, the color of developed prints changes to blue, while with later, reddish impressions are obtained. The most common reagent for fixing iodine developed prints is 7,8-benzoflavone, the structure of which is shown in the given figure. A mixture of 2 ml of 10% 7,8-benzoflavone solution in dichloromethane and 100 ml of 0.1% iodine solution in cyclohexane is used for this purpose. Iodine in combination with 7,8 benzoflavone reagent may be used for developing old latent fingerprints on porous surfaces such as bond paper, newsprints, and facial tissue paper. The composition is non destructive and the documents remain unaltered. Sublimable or low boiling organic reagents may also be made to interact with and fix iodine absorbed on the latent fingerprints used in vapor state. For example, iodine interacts with alpha naphthylamine to form a red colored charge transfer complex. Although free iodine does not possess a natural dipole moment, yet, in concert with an aromatic system, it requires an induced dipole. The combination of electron rich aromatic compounds and dipolar iodine results in charge transfer complexation. The charge transfer complex is non volatile in nature and hence it does not evaporate from the frictional ridges. As a result, the developed prints do not fade out with passage of time. Representative fingerprints developed on different items are depicted in the given figures. Now let us see assessment of iodine method. The iodine method for detecting latent fingerprints has following advantages. Number 1, the procedure is very simple to use and requires only a meager degree of skill and experience. Number 2, with conventional chemical developing reagents, the latent fingerprints on the surface in question are first visually searched and then the relevant spray or powder formulation is applied. However, while using the iodine method, there is no need to first scan the surface. Iodine vapors on their own get preferentially absorbed on the fingerprint residue, revealing the ridges. Number 3, a number of chemical fingerprint development methods such as ninhydrin, cyanoacrylate, and silver nitrate require instrumental detection techniques such as laser and neutron activation analysis and therefore cannot be used for on the scene investigation. The object bearing the latent finger marks has to be carried to the fingerprint lab if any of these methods is desired to be used. However, iodine in conjunction with 7,8 benzoflavone may be used for detection of fingerprints at the scene of crime. D. Iodine fuming is a sensitive method for developing latent fingerprints on porous surface such as paper and paper products. The other reliable method for porous surface is the ninhydrin technique. However, good results are obtained by ninhydrin only after the developed fingerprints are treated with metal salts following by laser examination. No such costly equipment is required with iodine. E. Iodine fuming develops both fresh and relatively old prints. F. Iodine fuming is one of the techniques which can develop fingerprints on human skin. The area of skin suspected to be impinged with latent print is treated with iodine vapors. Once the impression appears, these are pressed onto a silver plate. Exposure of the plate to light reveals permanent finger marks. G. If in a particular casework investigation, iodine method fails to detect fingerprints on crime scene evidence, other techniques like ninhydrin method may still be tried out. Iodine method suffers from the following shortcoming. A. The iodine developed fingerprints fade out in a short time. Hence, these have to be fixed using a suitable reagent. Yet, it is pertinent to state here that other fingerprint detecting techniques such as powder dusting, ninhydrin spraying, and cyanoacrylate fuming do give good results only after post treatment operations. B. Iodine is toxic and poses occupational hazard to the user. Nevertheless, by observing some simple safety precautions, this problem may be eliminated. Now, my dear students, let us discuss a case study. Iodine fumes are sensitive to different latent residues than other methods. It is possible that latent prints that would have been developed by iodine fumes will not be developed by other means, whose application will then destroy the residue needed for iodine development. When the nature of surface is questionable as to a particular technique or sequence of techniques, iodine fuming should definitely be considered. That was the case some years involving a piece of surgical tape. The white surgical tape had been used to bind a victim in a sexual assault incident. The victim was able to eventually free herself and tear off the tape. A piece of the tape was recovered from water in a toilet bowl where it had come to rest. The tape was submitted to the lab for examination. This was before the development of the special adhesive tape powder. It was decided to use an iodine fuming device on the adhesive side of the surgical tape. An excellent fingerprint, almost resembling a rolled fingerprint, was developed, photographed, and subsequently identified to the left thumb of the assailant. Early techniques may be old but still viable. All techniques should be considered in their proper sequence in efforts to locate and recover latent prints of value to an investigation. My dear students, let us summarize this chapter now. In this chapter, we have learned that iodine method has traditionally been very popular for processing imprints on porous surfaces. Then we have come to know that the method relies on the physical absorption of iodine vapors on the fatty acid content of fingerprint residue. And we have learned that several post treatment options are available to enhance the stability of developed prints. And lastly, we have learned that in case prints fail to develop by iodine method, other methods of fingerprint detection may still be tried out. The reverse is not true.